Do you have to design unique products with standard components? I'm Vince Penman.
And I'm Allison Tupperwine. Today on the Product Design Show, we look at overcoming the challenges of standard size components.
Many product designers are faced with standard size components that must be cut down or squished to fit a new product. Nowhere is that problem more prevalent than in the construction industry, where every component from 2x4s to sheets of plywood are modeled on standard sizes.
It's efficient for builders to use standard sizes, but it really constrains designs. When was the last time you saw a house that wasn't a rectangular box? Now imagine that you wanted to fit a curve to a roof liner or a window. You might have to make the building supplies yourself.
Or on a larger project, how could you fit a curve to a concrete bridge? We spoke with Dutch architect Gijs Jossen of ONL, Oysters Lennart, about using standard size components to create non-standard designs.
Gijs explained how the ONL firm designed this free-flowing bicycle bridge. The spline is a smooth curve with no apparent beginning nor end, and more importantly, without a fixed radius like a traditional arc. The normal approach would be to have a straight on-ramp on either end connected in the middle by a fillet arc. When Gijs decided to continually change the radius of the curve, he introduced a host of design challenges.
The concrete for the bridge was to be poured on site, but the carpenters making the concrete molds had only standard sized plywood. The answer? Segment the model into pieces, each of which is no bigger than a sheet of plywood. Then use parametric modeling software to design the shape of every piece of plywood. In this case, the panels were pre-cut using a CNC-controlled cutting machine.
The instruction sets that the architects created were as challenging as an IKEA bedroom kit made from Lego. But in the end, the pieces fit together smoothly and the flowing curves were created.
Here's another example from the same architect. This flowing highway barrier in High Rhine is designed to provide a beautiful visual shield while reducing the highway noise to the neighborhood. It will be made of steel mesh and built on site. You know, I could use one of these to block my view of my elderly neighbor going for a Speedo-clad dip in his kiddie pool. The barrier is in the final design stage. Building will start in 2012.
The barrier has to maximize the use of the land on the side opposite to the highway. The property lines aren't straight. The team at ONL used Creo parametric modeling software to make the base of the barrier track the property line while preserving the visual feel of the nearly straight center and top lines.
This structure was designed with 100% custom steel parts, with every part specified separately. The steel tubes will be joined together at unique angles using custom fabricated connectors. Every connector has a unique set of angles to join up the 6 steel tubes. It's a unique mass construction project.
Gijs told us that these kinds of designs wouldn't have been possible before computer modeling. There are just too many parameters to manipulate and too many changes along the way.
You can see Creo Parametric in action. It's the same software that ONL used to design the feature lines for the bridge and noise barriers in this episode. Just go to ptc.com/go/Creo Parametric to see for yourself. If you like the show, please give it a like on Facebook, subscribe on YouTube, or give us a rating on iTunes. We'll see you next week for more great design engineering.